let's try sketching this region. And I think there's a reasonable thing here that you might start from the left and read in, right?
Okay.
Don't do that. Start from the inside and read out.
I thought that's what we were doing.
Yeah.
Yeah, so just like function evaluation, right? You need to start at the inside. Okay. So all I want to do is sketch the region of integration for this thing. So I should start with the first thing first, which is that z's, right? Z's my first thing.
Yeah.
How do I know z's the first thing?
Well, DZ.
Good, dz's on the inside, right?
Yeah.
So once dz's on the inside, I know z's my first thing. Where do the z's start?
From 0
to the square root of 1 minus x squared.
Okay, so they go from 0 to... Yeah, and maybe really I should phrase this as they go from z equals 0, right? To z equals the square root of 1 minus x squared.
So then...
The positive semicircle in
Good.
the x, y.
Cool. So the z's, right? The heights, they go from 0 to this thing looks like a circle, right?
Yeah.
How do you know that's a circle? Just have to get to know it.
So if I squared both sides, I'd get z squared is 1 minus x squared.
It's the same as 1 squared.
So I'd get z squared plus x squared is 1 squared.
Okay.
Yeah, and then what? And then it would just be.
And then I noticed that this is only the positive half y.
The positive half? Because it's from.
Yeah, Donald's right, it's a semicircle. And it doesn't have the plus
At least
or minus.
z.
Right, if I solved for z, I'd get a plus or minus.
Okay.
So if I was doing the whole circle, right, z would range from minus the square root of whatever to plus the square root of whatever.
Okay.
Cool. So I know
They're
the
so
z's
bright.
go from 0 up to that semicircle. Okay, so my z's look like this, right?
Okay.
Okay. Then, maybe I should figure out more fully what that graph looks like. So I know I've got a z-axis this way. What's the other axis here?
That's x.
That's the x-axis, right? That's my circle. It's in x and z. What about y?
Y.
I'm supposed to be doing three-dimensional stuff, right?
Yeah, y sticking.
Yeah, y goes that way,
Yeah.
right?
And y equals 0 in that equation, right?
So what does that equation tell you about
It
about
doesn't
y?
tell us anything about
Yeah, it doesn't tell you anything about y, right?
Yeah.
So what does that mean about y?
That's it.
Yeah, it can be anything, right?
Yeah.
So I take this semicircle and I go, boom,
Yeah.
run it out in both z, or both in,
Both ends
run
of-
it out along the y-axis, right?
Okay.
So I'm going to get this kind of,
And how come you did the y first before the x?
so at this point I'm just trying to conceptualize what
Okay.
x squared plus z squared is 1 looks like. And I know that's going to be the important bit, right? Because that's where the z's happen. Now, if the x's had some variables here, then we'd talk about cutting. But the fundamental object we're going to start with is this kind of half a tube run out. And really I should run this forward too, right? You see that?
Yeah.
'Cause I don't know that y has to be positive. So I should really run it at me as well.
Okay.
So because the integrals from 0 to 1 doesn't really necessarily mean it starts at 0.
It will.
Okay.
Yeah, absolutely. So, you guys see that? So let's move to the next variable. Next variable is x, right?
Yeah.
Where do the x's range?
Negative 1 to 1.
So the edges.
Yeah.
Okay, the x's range from here to here. So I'm not modifying the picture at all, right? Okay. How about the y's? Where do the y's range from?
0 to 1.
They range from 0 to 1, right? So I don't need to worry about the negative y, so I can cut off this bit, re-solidify.
And it goes away to 1.
And it only goes to 1, so I can cut off the back bit too. And I know that this point here is something like, it's got coordinates for me for that.
That point.
1,
1, 1,
and that's going to be 0.
0.
Where'd you get one?
Because
Where'd I
it's-
get 1, 1, 0?
That's the
So
farthest.
it's 1 in the X because it's on the end of that semicircle.
Oh, okay.
It's 0 in the Z because it's on the XY plane.
And then it's from 0, 1 to 1.
And it's 1 in the Y because that's where it ends, right? So what I get here is I get the, like, here's my region of integration.
That's an edge.
Clean my picture up a little bit. Okay, so if I wanted to clean my picture up a bit more, right? I'm drawing kind of tube like this.
Okay.
Cool.
Yeah.
And then we could label points on the tube. But really, fundamentally, that's the region you're integrating over. And that thing is that filled in or is that a shell or what?
Filled in.
Yeah,
That's
I'm
what-
integrating over that thing filled in, right?
And since this will slightly tie into the next question, that interval would always be positive.
It depends.
Depends.
Is the function you're so right? This thing that I'm doing, right, is asking if I integrate over that region f.
Mm-hmm.
If I think about f as a density function, how much does this thing weigh? Well, if the density is negative, then the weight could certainly be negative. It doesn't make much sense physically, right? But of course, I can conceive that if the density were negative, then it would.
If you're doing like a temperature function and you're looking for the average temperature.
Perfect. Yeah. So if I was looking for the total energy in this system, right? And I just wanted to integrate the temperature and then divide by the kind of volume of this region. Yeah, I could definitely get a negative number out of that. You guys cool with that?
Yeah.
Questions on this thing? Yeah.
Would you modify the x so that we can figure out what it would look like if one of the endpoints was a function? Like z?
Sure. So if we modified the question, right? Like if this guy, what's a valid input I could put in here for?
0 to y.
Yeah. So the x's, right? Those can depend only on y. They can't, of course, depend on z. You guys see that? Because I already integrated the z's out at this point. But I could throw a y in here. And then what would that be? Yeah, so that would say my x's, right? They range from y to 1.
Then there would be a function y in the picture.
Mm-hmm. So what's the function x equals y look like? You guys see that? That's really what I'm thinking. What's x equals y look like?
Plane cut.
Just a, yeah.
That looks like this plane, right?
Little chunk.
Right, the plane made by the line y equals x. So
Yeah.
what am I going to get? Well, I'm going to
Yeah.
get something that looks like this thing cut.
So more like the melon thing, kind of.
Oops. Huh. My bad.
Yeah.
What did I just do wrong?
It was
Your
still
square
arcing
bottom
in the
modifier.
Yeah, this was supposed to be triangular, right?
Okay.
You guys see
Like
that?
half of that.
Yeah, so I've got a half a tube, right? So if I flipped over one of the benches, actually, what the hell? What's wrong? That's the awesome thing about these benches. So if we flipped over one of our benches, right? So here's my. Okay, so in my picture, right, I've got a.
Semicircle thing.
Yeah, I've got a semicircular tube, right?
Yeah.
So this is z
Z.
equals the square root of
1 minus x.
1 minus
squared.
x squared, which forces the origin to be someplace along the middle. So let's call it here.
Okay.
Then I've got, where are my axes?
X would be this
Well,
way and then
Perfect.
y
X is this
through,
way. Y is along it,
Yeah. And then z
and
is
z
the
is up. Okay. And then if I think about that plane, y equals x, right? That's me looking at these two axes, drawing the line y equals x in it, and then sweeping it through the z's, right?
Yeah,
So that's going to look something like,
a sharp cut.
yeah, cut like this. You
Okay.
guys see that?
Of course, the video got
Just can't see that. So there's my chunk, right?
Yeah.
And of course, we could take a chainsaw, cut that thing off, and figure out exactly what the volume is, right?
Yeah, so we won't. Well, you don't.
Cool.
I'm